This lesson is about special types of factoring. The first kind of factoring that we want to touch on is the difference of two squares. That means that we're going to have a difference, which means subtraction, of an expression that is squared minus another expression that is squared. And the formula for that is if you have x squared minus y squared, it's x plus y times x minus y. The best way to see this in action is to look at a few examples. So first, we need to be able to recognize in this first example that 25 is actually 5 squared, and 81 is actually 9 squared. And I know this is going to factor as two factors, one with a plus sign in the middle and one with a minus sign in the middle. So I look at this first term and I say what's squared there, and it turns out both the 5 and the a. So I'm going to put that at the beginning of each one of these factors. And what is squared in this second term would be 3 and b, and we'll put 3b in the second one. So this is actually the result of factoring this, but just to be sure, we could multiply this out. So if I multiply 5a times 5a, I'll get 25a squared. If I multiply the outsides, I will get minus 15ab. The insides will give me plus 15ab, and the last will give me minus 9b squared. And what you should notice is that these two middle terms add to 0, and we're left with 25a squared minus 9b squared. For this second example, 2 minus 98z squared, I'm looking at it and I'm thinking 2 is not a perfect square and 98 is also not a perfect square. But you might notice that I could factor out a greatest common factor of 2. That would leave me with 1 minus 49z squared. And I do notice that 49 is 7 squared. So this is going to factor as 1, because 1 times 1 will give me this 1 here in the first term, plus 7z and minus 7z. Here are a few more examples. First, note you cannot factor a sum of two squares. So even though in this first example we know that 64 is a perfect square and we know that 9 is a perfect square, it's not the difference of two squares, so this does not factor. For this next example, we know that 1 is 1 squared, 16 is 4 squared, and we will break this up into two factors. One of them will be plus, and one of them will be minus. The thing that is squared here is 1, and for our second term it is 4t. And there we have the factored form of 1 minus 16t squared. This last example is maybe a little trickier. It doesn't appear that this is a perfect square at all. It's raised to the 4th power. But we can think of this as x squared squared minus 2 squared y squared. So when we factor this one and we ask ourselves, what is squared here? We'll say x squared. And for our second term, we notice that both the 2 and the y are squared, so we get 2y and 2y. And again, one of these factors is plus and one of these factors is minus. The next kind of factoring we want to look at is the sum and the difference of two cubes. So here, instead of a perfect square, we're going to have a perfect cube minus a perfect cube, or a perfect cube plus a perfect cube. In each case, you'll notice that these look slightly different. It's just the signs that are different. And there's a mnemonic that I use called SOAP that will help you remember what signs you need to have. So you'll notice that this is a minus sign, and this one is the same. That is what the S stands for, same. The next one is opposite of this original sign. That is opposite. And this last one is always positive. And you'll notice it does the exact same thing over here. That is the same. This is opposite, and this one is always positive. So when we decide that we're going to factor, we notice that we have a difference of cubes and we want to factor maybe something like 8x cubed minus 27. And I say, well, this is 2 cubed x cubed, and this is just 3 cubed. I notice that they're a cube minus a cube. So I'm going to break this up as 2 factors, and the first thing I'm going to do is put my signs in. So since this original was a minus, I'm going to put the same sign here, the opposite sign here, and this one will always be positive. Then I'm going to ask myself, what is cubed here? It's the 2 and the x. That's what I'm going to put in the first spot. Here, I'm going to square the 2 and the x and get 4x squared. Then I'm going to look here and say, this is a 3, not a 2. I'm going to say, what's cubed here? And I'm going to say, well, that is a 3. So I'm going to put a 3 here. And then over here, I'm going to square it, and I'm going to get 9. The last thing I do is I want to multiply the 2x and the 3 together, giving me 6x. And that's what's going to go here in the middle. So again, if we multiply this out, we should be able to see this. Here we'll get 8x cubed plus 12x squared plus 18x. When I distribute the minus 3, I will get minus 12x squared, minus 18x, and minus 27. And you will notice that these 4 middle terms are actually going to add to 0, leaving us with 8x cubed minus 27. So we're going to do more examples on the next page. Here we have a simple x cubed plus 8. So we know this is going to factor into a small factor and a large factor. And my signs, I'm going to look at this plus sign and say same, opposite, always positive. What's cubed here is an x. I will square it and put it here. What's cubed here is 2. I will put it here, and I will square it and put it here. The only thing I still have to do is multiply these two together, giving me a 2x, and that's what's going to go here in the middle. So I think if you build this, it's a little bit easier. Now sometimes you have to be able to recognize that the numbers in your polynomial are actually perfect cubes. So 64 happens to be 4 cubed. And 125 happens to be 5 cubed. So when we factor this one with our small factor and our large factor, the signs, looking at this original minus sign, will be the same, opposite, and always positive. When I fill in this first slot, I look here and say, what's cubed? 4 and y. And then I can fill in this slot by squaring it, 16y squared. When I look at the second piece, I can say that the 5 is cubed. Squaring it will give me 25. And then when I multiply these together, these two terms right here, 4 times 5 is 20y. I don't have to worry about the signs because I've already put those into my factored form. Good luck. I'll see you next time.